Okay. Hi, I am Mano Marks. I'm a developer advocate on the Google Maps team. This is Sean Maday.
I'm Sean Maday. I'm a geoengineer on the enterprise team.
So it is our pleasure to do this session today. We're really happy to see you and everybody on live stream. Hi. So I want to talk a little bit of history here. Some of you may have gone to the session yesterday, What's New in Google Maps. And Brian McClendon talked a little bit about where we started. And this is the first Google Maps. This is Google Maps beta in 2006. We started out with points and driving directions, and it was a really revolutionary interface at the time. At the time, if you wanted a map, you had to go to a map image, and if you wanted to zoom or pan, you had to click and load a whole nother image. It'd probably be a little iframe that would refresh and be like 10 seconds, because this was the internet back then. And what Google did was it looked at that and thought, wouldn't it be fantastic if we could do a better experience, a nicer, smoother experience that would not require this sort of disengagement from the user. And so we released what has now become a very standard way to do maps online. Google started this sort of tile serving infrastructure using a JavaScript-y interface, which allows you to dynamically move and pan your maps and add things to it without having these huge lag times, just an exploration of the map of the world. And we incorporated map tiles and satellite imagery all around the world, and it became this sensation. So much so that people, within days of seeing this, had reverse engineered it and told us, hey, look, we can do really amazing, cool things. And so in 2006, we actually released the Google Maps API, version 1, and asked developers to come with us on this journey of exploration of the world, of geospatially organizing the world's information. And they did. You did, right? If you're in this room, you probably have written a Maps API application. If you are a web developer, you have probably written a Google Maps API application. There are 800,000 active websites. That's active websites using the Google Maps API right now. 800,000, and it continues to grow at a really huge rate. So in 2006, we asked you to do this journey with us, and now you have, and we are now asking you to do it again. Because as Brian talked about yesterday, there are still dragons at the edges of the map. Referencing old European maps, which used to say, here be dragons at the outskirts of your map, where they didn't have data. So we want you to join us on this journey to get rid of dragons, this adventure, to get rid of dragons. He actually called it dragon slaying. Yeah, we're going to slay some dragons. So we want you to join us, and we want you to do it the way we do it. We want to make our infrastructure available to you to serve out maps in the way that we did it, and learning the lessons that we have of creating a really incredibly developed infrastructure for serving out maps data. And we want you to be able to do the same for your organization. So please, they always tell you to do a call to action in these. I'm going to do the call to action early. Call to action is join us in this adventure. Okay, so let's talk about what that means. That means is we want you to build your maps in our cloud. We want you to reach users on every platform that you can reach. And we want you to integrate our data with your data in your applications. 3 basic key takeaways. If you don't remember anything else, you remember. If you're watching on the live stream, you should still watch the rest of it, but if you, those are the key takeaways. Okay, let's talk about what that actually means. This right here is a Maps API application. Now, you may say it looks like a fairly standard Maps API application. I didn't gussy it up because I'm not really a designer. But think about it this way. Think about if you were the state of Louisiana, or not literally the state of Louisiana, but you are a representative of the state of Louisiana, and you're concerned about the impact of oil, natural gas, infrastructure on disaster preparedness. So you want to visualize where things are. So we actually went out and did this. Sean found a great site provided by the state, right, the state of Louisiana, that had data about where things were. And we put that on this Maps API application. So here are the Haynesville shale wells. Here are some oil and gas fields. Here are some permit points for new permits for drilling, I'm guessing. And polygons that impact the areas where these are. Here's some levees. You get the idea, right? We have lots of interesting data about where things are. Well, here's the trick. So you've probably seen Maps API applications like this before, but all this data is actually being served off of Google's infrastructure. This is all data that's living in Google Maps engine and is being served directly to a Maps API application. The only thing that is not on Google's infrastructure is the sample. This is a HTML5 slide deck. I have an HTML page and some JavaScript just sitting on my laptop, but it could be on a server somewhere. And that's it. All the data is served directly from our servers in a highly optimized fashion. And I can share that data with whoever I want. I've made this public because I'm making a demonstration, but I could limit access to who can do what with this data. So think about this as an example. Sean's going to walk you through a little bit more, but first I want to talk to you about what the cloud looks like. Why should you think about our geospatial cloud? Google Maps is used 1 million hours every day. For 1 million hours, people are using our infrastructure. We have 1 billion monthly active users of Google Maps services, and how many of you know about Santa Tracker? Seen Santa Tracker? All right. You guys are part of the 1.6 million queries per second that our infrastructure handled on Christmas Day, when some very brave data center engineers stayed during Christmas Day, probably fairly alone in the data centers, making sure that Santa Tracker stayed up and running. 1.6 million queries per second. So we have a solid infrastructure that we've developed that will help you serve your data when you need it. And during the lean times, when you don't have very many users, and during the high peak periods. That's what you should be thinking about. But there's more. We have available for your use the world's largest imagery database, 20 petabytes of imagery. That's just the data that we make available through Maps. We have a constantly updating base data, so the maps are being updated moment to moment. We have people in MapMaker. We have a project called Ground Truth, where we're actually sourcing our own data and inputting it. And we also have additional data providers. So we have a massive amount of base data constantly being updated. We provide you with access control, rock-solid access control. So if you're familiar with, how many of you use Google Docs? and Gmail. All right, I mean, it's Google I/O, that's not a fair question, right? But, but you know then about access control. You can make a document public, you can make it private, you can make it unlisted, and we give you additional access control, but it's based on the same solid infrastructure. So security and stability. And we have API integration. We have the world's most popular web API, the Google Maps API. I'm not kidding when I say probably everybody in this room and everybody watching has done a Google Maps API application. I'm sure somebody's going to tweet me later or plus me later and be like, I haven't. But you know, statistically speaking, almost all web developers, anybody who's done JavaScript, lots of people learn JavaScript by actually developing Maps API applications. It's simple and powerful, huge amount of features, huge amount of services. So that's why you should be trusting our cloud. Now, Sean is going to talk to you about the details of Maps Engine.
All right, thank you, Mano. As Mano described to you, we at Google have gotten really good at this geospatial stuff. Consumers around the world trust our two-dimensional maps and our three-dimensional Google Earth environment to make fast, informed decisions. It's that familiarity that we look to leverage with Google Maps Engine. I should ask, how many of you have used Google Maps Engine or put your hands on this product to this point? Good, okay. Oh. So for those joining us via live stream, the thousands of people in the audience all raised their hands. And their applause and laughter and cheer was actually a bit disruptive, but we're back now. Google Maps Engine is how we have basically productized the processes and the pipelines that we used to make the platform behind Google Earth and Google Maps. So we have really awesome engineers, outstanding infrastructure that does lots of really cool things with geospatial data. Specifically, our core competency has become simplifying the delivery of complex geospatial data. And that's what we're offering with Google Maps Engine. Google Maps Engine allows you to take your imagery, terrain, and vector data, upload it into Google's cloud. It's replicated in our data centers. We handle the redundancy. We handle the failover. You then are given tens of thousands of processing nodes to do interesting things, to process your data and to style your data, and then all sorts of interesting endpoints to deliver your data out to your intended audience, whether that audience is public or whether you just want to share your data with certain individuals or groups. And we'll talk through more of this as we go. But these endpoints include Google Earth, Google Maps, the Google Maps API, OGC standards like WMS, as well as some mobile endpoints we'll display for you on a Zoom tablet here in a little while. So in the last 6 months, we've really kind of opened up the Google Maps Engine platform and brought in some trusted testers and some early customers to use this platform. And as Dylan Lorimer mentioned to you yesterday, we're now going to kind of increase the velocity by which we bring stakeholders in, and we're hoping to bring lots more individuals and organizations into this ecosystem. But to date, it's interesting to note that this platform is already hosting 165 terabytes of imagery. Our data store, our vector data store, is composed of over 2.5 billion features at this point, and that's growing exponentially. And today, Google Maps Engine is being used to serve over 1,000 published maps. So, small numbers by Google standards, but really some impressive usage and some impressive adoption in just these first few months. So as I present to you today, what I want to do is show you the Google Maps Engine interface. I want to get you familiar with some of the workflows. Specifically, I want to show you how to upload data, how that data is aggregated into individual layers, how you can style those layers, and then how you can publish a map to many of those different endpoints that I discussed previously. So as I kind of operate and show you the interface, we're going to be referencing back to the Louisiana oil and gas demo that Mano showed you earlier in the presentation. And my goal today is to show you kind of the workflow around two different types of data. That is imagery data, or raster data, and vector data. In regards to vector, I'm going to show you three different subsets: points, lines, and polygons, how these are handled inside of Google Maps Engine, and what tools we give you to style and deliver this data out to your users. So Mano showed you what we have as far as our base data around Louisiana. As we zoom in here, I'll then activate some of the layers that he presented to you a bit earlier. Specifically, we can look at some point data, like the permit locations. We can look at polygon data, i.e. the polygons that encompass those permitted areas. We can also look at line data, like the levees. And then, if our map weren't cluttered enough, we will go ahead and add some raster data. So here's a topographical chart, really interesting way to visualize topographical data, in this case that was housed by the USGS. And also imagery. So I grabbed a quad of ortho imagery here from USGS. We can throw that on top. This is a scene that Google doesn't have in our imagery database, but this is available to the public through USGS. And what I really want to highlight here is that the Google Maps Engine platform is a really unique way to deliver all this data to the end user in a simplified way. Any user who's familiar with Google Maps, zooming, panning, interrogating icons by clicking on them, will be familiar with this workflow. And the engineering we've done in the background makes this delivery fast and efficient, so the user's not sitting around waiting for this data to render.
Oh, John, one key point. Where does this iframe come from?
Yeah, great point there, Mano. So this iframe is actually being populated right now by a Maps widget, which is another endpoint that we have within Google Maps Engine. I'll show you a bit later. But this is a little bit of embed code that we provide you. So at the very simplest implementation, you can put one line of HTML code into your organization's website or into the public-facing website that you want to use to support a disaster response or humanitarian relief type situation, and have all of this Maps interaction inside of your web environment. So one other thing I want to touch on before I jump into the live interface demo is this concept of zoom levels. Zoom levels are the way that we handle the delivery of tiles inside of the Google Maps environment. So if you're delivering a map, you have a couple options. One is to produce a really large map, high resolution, and that can be difficult to interact with, right? The other option is to give you a small image that has very low resolution. What Google Maps API and Google Maps has done is they use a tiling schema so that when you're zoomed way out looking at the whole world, we're just delivering you a couple tiles that represent the world in low resolution. And as you zoom in, you're seeing more tiles. Each tile is smaller, and those tiles represent higher resolution areas. The reason this is important is because on the Google Maps environment that we provide on consumer devices and to the average public, we have a vector team that's done a phenomenal job of making sure that the right attributes are visible at the right zoom levels. So for instance, when I'm zoomed out and looking at the United States here, I'm not seeing every secondary and tertiary street that's available. In this case, at this zoom level, it may be appropriate for me not to see any streets at all. Maybe just the labels associated with states. As I zoom in further here, I start to see interstate highways. As I zoom in further yet, I'll start to see smaller municipalities and smaller infrastructure pieces. This is all important because in Google Maps Engine, we give you the tools to style your own data and to decide how that data should be presented to your audience. And this chart is handy only in that as we style some of this data in the demo next, I just want you to keep in mind that when you see these zoom levels, this is what we're talking about. Zoom level 5, we're talking about being zoomed way out at a global view. Zoom levels 17, 18 to 24, we're talking about being zoomed way in where you could see a building or a street. Without further ado then, we will step off and show you Google Maps Engine. So this is the landing page or the dashboard that currently exists for Google Maps Engine. The first thing you'll notice is that inside this dashboard I have some analytics. So some basic metrics on how many of my layers are being consumed and when my peak usage is happening. I can also do some querying based on time to really identify when my map data is being consumed. The basic building blocks inside of Google Maps Engine are data, layers, and maps. Data is the raw source information and the raw source files that you might currently have in your geospatial repository. Those are aggregated up into layers and styled in layers inside of Google Maps Engine. And then layers are brought together as maps. Example of a map would be the Louisiana oil and gas demo we just showed. So the first piece here is data ingest. So what I'll show you here is how we would upload a piece of source data. The upload interface is fairly simple. It's just going to ask me right off the bat if I'm going to upload imagery or vector data. For this demo, I'm just going to show you what it would be like to upload some imagery. This is always the dangerous part of the presentation, though, because I'm going to browse to a piece of imagery, and if I do this wrong, I'm going to end up in a folder that has all of my Justin Bieber images, and you will forever taunt me. So we have to make sure we land in the right place here. Here, for example, is one of those USGS quads. It's a .tiff file. Google Maps Engine will consume GeoTIFFs, JPEG 2000s, Mr. SID, most of the industry standard raster formats. In addition to that core source piece of data, we will also take sidecar files, like world files or projection files that might provide amplifying metadata associated with that image or that vector data. So in this case, I don't want to just include the TIFF. I'm going to include the world file and maybe even one of the attribute files that's associated with it. From here, I have the ability to name that layer. It's going to default to whatever the file was named, but I could put in anything here that made sense to my individual project. I can then decide who I initially want to share these layers with. The relevance and the importance of this sharing is really that inside of the Google Maps ecosystem, you can have many map makers. Map makers are those who can style data and compose maps based on the layers. So in this case, I can decide which group or which individuals inside of my organization I want to share this layer with. And then I can assign attribution. Attribution is a catalog of source information, source provider information that you cultivate and you populate inside of your Google Maps Engine environment. It allows you to very quickly add attribution to your Google Earth or Google Maps endpoint. You can put in the data acquired. This is very handy if you're going to do some temporal-based positioning or if you're going to show historic imagery or historic raster. This is very important because you can leverage this in a few different ways. You can throw in a description, and then tags are very significant because tags are what allow us to actually make this data discoverable and searchable inside of our Google Maps Engine implementation. So I'm actually going to cancel that and show you what this looks like once it's already uploaded. I'll save you the excitement of watching that upload dialog progress. But what I can do now is I can search for some of this data. So up in the search bar here, I'm going to search for Louisiana. Here's all of the layers that I have branded with that Louisiana keyword tag. Here is the raster layer I was just showing you. This has been uploaded and processed. Google Maps Engine is extremely fast at processing and has gotten faster even in the last 6 months. So it can do really wild things with large chunks of data. The raw size for this particular image was 110 megabytes, but now we can deliver those out as small consumable map tiles for the end user. We get some information on the resolution. In this case, we see this piece was 2.4 meters per pixel, which equates to a zoom level 16. So back to our pyramid, this would be good to about zoom level 16. And from here, I can then aggregate this data into a layer. So if I do another search of my layers now to show you what my Louisiana data looks like, I can show you all the layers that I have built using this Louisiana data. Specifically, I want to show you some of the point data we talked about earlier. In this case, it's the oil and gas locations. It's the oil and gas wells. One thing you'll notice is I get this thumbnail preview in the upper right-hand corner, which shows me the geographic parameters of this particular file. Interesting to note here that this layer of Louisiana oil and gas actually shows me that I have coverage all the way up the center of the United States through the Mississippi corridor. What we can look and QC, quality check here with the preview, and we'll let this render here in a second, but what we can see is that the quality of this input data wasn't great. And in fact, this Louisiana oil and gas data will show me a couple wells that are located in northern Minnesota. So the point I want to make there is that this is not a tool right now for editing and for curating your core geospatial data. And if you want to make sure that the data you upload has been quality checked before you bring it into this ecosystem. Let me see if I can actually, there's our delinquent well there way up in Minnesota that's throwing us off. So the point being there that, again, we're not here to replace your existing desktop GIS-based systems. The systems you use to generate and cultivate this data are important. We're just going to become the visualization layer that allows you to easily share this information with your users. From here, I can edit this layer. And this is where I wanted to show you zoom levels. So I have basic options here to assign either some point icons, some place marker icons, or do some different stylization on these individual points. Interesting to note there that right now we don't support custom icons, but that's coming very soon. And what I really want to hit home with that is that there's some really rapid development cycles inside of this ecosystem. And the benefit of a cloud-based environment like this is that we are on a very fast release cycle where we're pushing these things out every few weeks. And your users and your map makers will be able to take advantage of this functionality without installing the latest software, without going through an IT change management process. One of the benefits of the cloud is as fast as we can roll out these new features, they're going to be available to you and your map makers. From here, then, I can decide when these individual well attributes should be available at which zoom level. I can also set up some dynamic filters based on the attributes inside of that source data. So maybe if you're zoomed way out, I want to show you large wells that have a certain production value that is quantified inside of the attribute table. In that case, I can set up some pretty simple greater than, less than, equal to type equations here to really specify what portions of the data I want to be available at each layer. I can dynamically cascade those filters down and really create a customized view for my end users. The same basic workflow exists for line and polygon data. I'll show you that just with levees, again, to hit home that this is all very customizable. In this case, we could decide what colors we want the levee to be, full color palette to choose from. We could decide how we want to style those lines. We can also decide how we want to present labels. And again, using the cascading filtering, we could decide that maybe we want labels on at a certain viewpoint, but we want the labels to drop off and become invisible once the user is drilled into a certain zoom level. All of that's customizable inside the Google Maps engine, vector-based styling UI. Finally, these layers are all aggregated inside of maps. We'll let this load here, and what I want to specifically show you, and what I can search, there we go, is what these maps look like. So here's my Louisiana oil and gas map. It's going to show me all the layers that I have aggregated inside of this map. It's going to give me some metadata about when it was processed, when it was published. And this is where I can really set some granular sharing parameters. So very much like the sharing parameters inside of Google Docs, if you've used those, I can decide which other groups inside my organization I want to be able to edit and modify this map. And then I can decide how I want to handle the viewing, the map user side of this particular data. I can decide to share this layer publicly. I can decide to share this layer with just a specific set of group or individuals. And then finally, here is my gateway into all those endpoints we talked about earlier. So this is the URL I could click on to interact with this map in a Google Maps API environment. The Maps widget that Mano asked about earlier, the iframe code, this is all I would need to paste into my web server in order to bring this Google Maps environment inside of my website. And then also we have a WMS link here. The benefit with WMS is that now we can consume this raster and vector data inside of our traditional desktop GIS systems. So for instance, if I have a cadre of QGIS users or ArcMap users, this one environment can serve the geospatial needs of my entire organization and any partner organizations I might bring into my ecosystem on an ad hoc basis. Specifically there, I'm thinking about disaster response or humanitarian relief, where you have private organizations partnering with public organizations in very dynamic relief efforts that are then over a month or 2 months later. And that's the power inside a Google Maps engine, is that you can very quickly share access to your data without giving up that source data, without having to move around gigabytes or megabytes of source data. You can share visibility and just as quickly revoke that visibility. Mano's going to talk to you a little bit more about some of the data behind our Maps API, or some of the usage behind our Maps API. But this is actually how I would reference these individual layers from Maps API. That's all detailed for me here as well. So the two things I want to show you before I step off then is first the integration with Google Earth, both in the client and in the web-based plugin. So I'll switch this over to Google Earth here. We'll give it a second. Maybe, possibly. It wouldn't be a true demo if something didn't go wrong, right? So the demo gods are unhappy. We didn't sacrifice to them before we started, so
sorry.
That's probably what happened.
Forgot that.
Do you have Google Earth on here? Do you mind if I launch it?
I have. You want to just open up Google Earth instead of the plugin?
Yeah.
And show that? Yeah, I do. So yeah, just go down to the.
Okay. So obviously I lied to you. This is Mano's computer, so those Justin Bieber pictures were his, not mine. I tried to defend him.
Train. I don't know what you're talking about. Yeah. It's train.
Yeah. All right. While Mano tries to fix that, let me show you what this looks like from a mobile endpoint, which is kind of cool. Let's see if we can bring this up here. All right, so what you're seeing here, what you should see here, is a Zoom tablet. Maybe. Who did we make angry? All right, I'll give this one more try. I swear this worked before the presentation without any trouble. All right, perfect, thank you. So here from inside of Google Earth, I can quickly zoom out. You'll notice now in the Android application we have for Google Earth, you can authenticate to Google Maps Engine. It will then build me a list of layers that I have access to based on the username and password that I use to authenticate to that Google Maps Engine. From there, I can activate the layer and then decide which of those layers I might want to see inside of my mobile environment on my Android device, whether that's a phone or a tablet. If you have the Google Maps downloaded on your Android device, I would highly encourage you to check this feature out. It's quite neat. Here you're seeing all the layers that I have access to. I can dynamically turn those layers on or off and view them as I see fit from this mobile device. Mano's logging into our Google Earth implementation over here on the desktop, so let me switch back over to his machine.
And there you see, I just went up to File and logged into Maps Engine. By the way, this is, you may have heard the old name for Maps Engine, which was Earth Builder. We rebranded about a month or so ago. And then you see here I have all the private maps that I have access to. I can also enter in a globe by address if it's a public map. So
similar to unlisted layers that you may have seen with implementations like Fusion tables.
Right, exactly. So then here I have the Louisiana oil and gas, and I'm going to click on that, go back to Google Earth, and you'll see down here in the layer section, I actually have Louisiana oil and gas. And so it's actually integrated directly with my experience in Google Earth. So as I zoom in, you'll see that I start to see some of this data showing up, different zoom levels that it's set for, and there you go.
The user can also control the opacity on this, so they can very quickly go from your enterprise geospatial layers back to Google's authoritative base globe information, all within the Google Earth environment that they know and love. One other endpoint we'll just discuss before I pass it back over is Google Earth Portable. Google Earth Portable is some really interesting software that our engineers have been working on. Allows you to draw a polygon around that Google Maps Engine implementation that you've created, extract all the imagery, terrain, and vector data inside of that polygon, and create a local cache of either two-dimensional map data or three-dimensional Google Earth data that your users, your field workers, can take with them out into an austere environment where they may not have connectivity back to Google's cloud. So that's one of the ways we're bridging that gap between ground and cloud. Appreciate your time, and I'll pass it over to Mano to run you through some of the developer options.
And actually, here is that Earth plugin that you were looking at before. It hadn't loaded up quickly, but that's because I had loaded in a new browser, and it's the first time I think it was using that cache. So this is directly loading off of Google Maps Engine, but it is using the Google Earth plugin, so it's a 3D environment within the browser, and you can actually do this with your own Earth API applications as well, which would allow you to combine with other sources of data that aren't hosted on Maps Engine. Okay, so I'm going to switch back to the slides. I turned off my clicker so I wouldn't bother Sean. There we go. Okay, so now we're going to talk about Google Maps Engine for developers. There are 4 different pieces that you need to remember about Maps Engine for developers at this point. We're in a fairly early stage. We have Maps data layer, which allows you to take maps and layers from Google Maps Engine and apply them directly to your Maps API applications. There's a JSON feed that you can get, which gives you access to information about what is stored in individual layers. You can also load a side database using the Earth API, which is similar to what I just showed you. And then if you need to do authentication, if it's a private map, you use OAuth. So we don't have time to get into the details of OAuth here, and frankly, authentication is a pain, but I'm sure there are other people here who can walk you through that. But just keep that in mind. So what we're going to be showing here is public maps, but this will be, if you can implement OAuth in your application, you can actually get access to private maps as well. Okay, so let's go back to this demo that we showed here. Now, this is, just as a reminder, same data. It's the same demo we showed at the beginning. And there's this USGS chart. Well, I click on it, and it's actually really tiny. It's right down in here. There's not a whole lot that's there. And then there's some ortho vector data. We just basically couldn't find some great raster data at the site where we were downloading data. So keep that in mind as we get back to it. But this is basically Maps data layer loading in that map that we've been working with. So here's some basic code here. You load in the Google Maps API loader. You use the visualization library. So if you're not familiar with that, libraries in the Google Maps API, we have a number of libraries, one of which is visualization, that are loaded as extra parameters to the loader. That is, if you don't load them, then the API knows nothing about them, so it reduces the size of your code. And then you create a new Maps data layer object and pass it map ID, layer ID, and the map that it's supposed to create on. And so these are the basic pieces. Remember, visualization, Maps data layer. And then what you get back as a piece of that, this is what the JSON object contains, the information here about your layer. And it gives you a lot of information in there, including the bounding box for a particular layer, a list of all the different layers that are associated with a particular map. And that allows you to do some processing to figure out how you want to display and interact with the data. And so some of the key stuff on here is asset IDs and the keys for the layers. So what I did in that demo before is I just used some jQuery to go through, parse out each of the layers, and add a checkbox with a event handler that triggers them on and off. So we're not done yet, but I want to give you a little, just a little thing to keep in your mind. We announced later this year that we're going to be announcing, we're going to be releasing a full read-write API for Maps Engine, which will allow you to upload your data programmatically to Google Maps Engine. Currently, that's not an option, but that is something that we are working on and believe that we can release within the year. And we think that will allow developers to do a much more dynamic approach to uploading, styling, and implementing data. Okay, but let's talk about a couple of other features of our geospatial cloud that aren't specifically tied to Maps Engine. And this will all come together in a minute. One thing that we released at Where 2.0 this year is the US demographics layer. So it's a layer that's available to enterprise Maps customers, if you have a Google Maps API for business. And if you have a Maps Engine, you get along a business license with that. So it's available for internal applications. And you'll see here that I get data from the US Census about things like income, population density, property values, and a lot more. So we're going to take a look at income in San Francisco in 2010. You can see the different census tracts in there have different income levels. And you can look back. We actually have the most recent census information. We can actually even show you the boundaries for the census block, so you get a nice sense of it. And then we also recently released, actually the first public announcement of it was yesterday. Dylan talked in the What's New in Google Maps API talk about the Google Maps Gallery. And also called the Google Earth Gallery. And in here you have lots of maps that people have created, KML files and also Maps engine files that people have uploaded and made public for anybody to have access to. So this is real-time sharing of public data. And you can do this if you have Maps engine. You can submit your maps to the Earth Gallery. So let's bring those together, though. Remember I mentioned that I was a little disappointed with the raster support in the state of Louisiana site. The raster imagery, we just didn't have very good coverage, we felt. So what we did here is I pulled into this Maps API application a separate Maps data layer. And I brought in topographic maps from the US Geological Society, USGS. And you see here, I can see the actual topographic maps. I can even see metadata about these if I'm at a zoom level. Well, that doesn't show up right there. But if I zoom in, you'll see I get a little metadata about each individual map, and I can actually see a bounding box of the different portions of that raster. So these are 3 layers provided in a different map, a public map made public in the Google Maps gallery. And I just loaded it directly into the Maps API application, the same one, or actually, slightly different file, obviously. And then I added in also demographics. So I can look and I can see at a glance, this is income by census tract. What I can see here is the impact that, for instance, permit polygons, where they are in relation to the demographics of that community. And I can tell, for instance, the impact that new drilling might have on low income or high income, whatever groups that I'm interested in, those different communities. So you can see by bringing these powerful visualization technologies together, I can do some really interesting analysis, visual analysis of my data, and layer in different features from different maps. Bringing it all together, and then serving it all off of the Google Geospatial infrastructure. Okay, so this is your next call to action. Tomorrow, Sean Woltman, the other Sean, as I like to call him. Actually, when I'm talking to Sean Woltman, I refer to Sean Maday as the other Sean. And Mike Avanoff are running a code lab here where you can actually play. Mike's in the back there. All right, Mike. Oh, there's Sean. Okay. This is the other Sean. Don't worry. They're going to run a code lab with a number of tutors. A number of people will be there to help out, where you can actually get your hands on Maps engine and play with it. And they're going to walk you through a lot of these steps, including, for instance, the OAuth stuff that I kind of glossed over because it doesn't really fit well in my nice presentation. But they'll cover that in detail, and you'll actually be able to get hands-on using this in a development environment. So I'm really excited that they're here, and I actually sat through a couple of their different practice sessions for it. It's really going to be great. So that concludes the presentation. We're really happy to have you here and happy to see that there's an interest in it. We're going to be, after this, we'll be out in the sandbox, at the Google Maps sandbox, so if you want to ask us additional questions. And we can take questions now. And of course, both of us are on Google Plus and Twitter, so you can find us there if you want to ask us questions out in the, well, that's not really the real world, is it? But
the real virtual
anyway,
world.
Yes. So thank you very much. So we can take questions right now. If you want to have a question, please come up to one of the 2 mics that are provided. Yes, go ahead.
Hi, thank you for telling us about this new exciting product. I was wondering about how Google Fusion Tables, the spatial aspect of that fits in with this. Is this a replacement, or do they work together, or is Fusion Tables being deprecated?
No, Fusion Tables is still an active product. It's part of Google Docs, and it does run on Google's infrastructure. It's a different kind of product. We saw the interest that was generated by that, particularly among Maps developers, and we got excited about that, and that was fed some. We learned a lot of lessons from that. We can actually serve, because it uses a different infrastructure for Maps Engine, we can actually serve a much greater amount of data. Do you want to give like the stats on like how big a map can be, how big your files can be?
Yeah, what we saw was that Fusion Tables really showed that there was a demand for doing lots of complex geospatial analysis in the cloud. So what we've tried to do with Maps Engine is provide vector tools that will handle tens of millions of vertices or hundreds of millions of vertices. So that's where we're really focused with Google Maps Engine is getting beyond those small use cases into those niche geospatial use cases where there's really fun things you can do with big data sets. So.
I spent a lot of time last year talking about Fusion Tables, and when I talked to people who worked in the geospatial industry, I would say, well, you could upload large amounts of data. They'd say, really? How much? I'd say, well, you can have files up to 100 megabytes that you can upload. And in the geospatial world, that's not a large amount of data. But for a lot of use cases, that is. So we think they fit into some different use cases, and also we've worked on the raster support, which isn't something that we can really do in Fusion Tables. So we think this is the enterprise, definitely the enterprise solution in the way we.
Yeah, if you need a service level agreement for tens of millions of vertices, Google Maps Engine is where we point you.
Right. And how large the files that you can upload?
So at this point, we can support several gigabyte files, and we're expecting that limit to grow exponentially in the months ahead. So we've got some really smart engineers who are doing great things with our vector store, and that's going to get big quick.
Yes.
I have a simple question that introduces a more difficult question.
I'll take the simple one. And then,
I'll
pass it
no,
to
they're
Mano.
very connected.
I'll take the hard one.
The simple one is about data visualization, rendering. Do you foresee to have the possibility to classify data based on an attribute of that data, so make dynamic classification? And this introduces the second one, which is how do you plan to evolve this product? Will it become a GIS product in the future? Thank you.
You want the first one?
Sure. So yeah, great question on classification of data. Specifically, I assume you're referring to raster data. We announced back at the COP16, the climate summit last year in Mexico, that we had been working on a platform we call Google Earth Engine, which starts to do some really neat raster analysis. We look forward to tighter integration of that platform with Google Maps Engine as these platforms both mature. But right now, the Google Maps and Google Earth Engine API is available to trusted testers, and if you want to start doing some raster analysis and classification, it's a really powerful platform for doing what you described.
Talk to David. He's in the audience right there with the hair for Earth Engine. So then the question is, does this become a GIS? And I guess it sort of depends on definitions of what is a GIS, and I've seen lots of conversations about that, particularly a few years ago, it was what is a GIS? At this point, what we're looking at is Maps Engine is really a way to serve and share your GIS data. And we are a platform for collaboration and a platform for integration. And we're also a way for you to reliably have your data in the cloud in a way that is not going to fail. So that's where we're at, and we're also looking at, we have this WMS, this WMS output, so we're looking at ways in which you can actually then use Maps Engine to integrate not just with your web applications, but with your GIS, other GIS applications. We're not done. This is we've been out for 6 months. We feel like it's a great product, and it's going to be really, really fantastic at some point. So we're really, come with us on this voyage. I think we're gonna have some really special stuff coming up.
And just to add to Mano's point, I would really challenge that this is GIS revisioned, reimagined, and our core competency again is simplifying the delivery of complex geospatial data. So my mom, my neighbor, when they want to understand geospatially what's happening in their neighborhood, they're not going to install a heavyweight GIS application on their desktop. This is a way we see ourselves as being that visualization layer that makes this consumable to everyone. So.
Yes?
You were talking about the ability to push edits using the read-write APIs.
Yes.
And I was wondering, have you decided to allow concurrent editing between multiple users that would show up in real time to all users? And if so, how do you handle data collisions?
You mean through the API?
Mm-hmm.
We haven't released any details on what the API is going to look like. So we are still, we've got the basic infrastructure for developing the API, but we haven't figured out all the details, and I don't want to promise to something that we can't. Yeah.
More to come on that. Okay. All right, any other questions?
Yes.
Sure.
You haven't been mentioning routing. Are there any plans for adding routing features in Maps Engine?
That's a good question. So you mean routing over your own data?
Yeah.
That's a really good question, and it's the kind of thing that comes up a lot. And the only thing that we have announced right now about future features is that we will have this read-write API. We can't tell you what other features until Dylan Lorimer tells us that we can. We can't tell you what other features are going to be part of it. But it's a really good question. I talk to developers around the world who are really interested in that kind of functionality. It's very hard to do, and we actually have solved it on our own systems. I'd love to be able to give that to you.
Yeah, and I would recommend too, stop by the sandbox and see what some of our partners are doing with this platform and all of our geo platforms.
GeoEye, I think, is there today. GeoEye provides much of our satellite imagery today, and they use Maps Engine as a way to work with partners and distribute their data. And they have some really, it's really great and inspiring to hear what they're doing. Other questions? Okay. Do you mind getting to the mic?
You presented the styling for the points. Do you have the same for polygons, polylines? Is it going to be a whole theming tool?
We do, yeah. So your question was on, if I heard you right, styling for points, lines, and polygons. Just in the interest of time, I kind of left off after I showed the styling of lines. But yeah, styling of polygons is in the tool today, and we only expect that those styling features are going to become more robust in the releases ahead. So I'll slowly kind of bring that up as we're talking here. But yes, the answer to your question is yes, we support that now. So here's the permit polygons. I have the ability to edit these styles with both the what the border should look like, thickness, color, and then the fill with not just the color but an opacity as well.
Once the API is out, would you be able to do that through the API?
Our goal is to provide a rich set of features through the API. So again, no specific announcements, but absolutely.
If you see Dylan Lorimer, you ask him. Get him a couple of drinks and maybe he'll tell you.
Tell you everything.
Any more questions? Okay, great. Thank you so much. Again, we'll be out in the sandbox.
Thanks, everybody.